everyone. So here's another bonus video. I doubt we're going to test on this because there's no good way to test you guys on it since you have calculators for your tests. But I think it's a worthwhile skill that I'll at least make a little video of here for dealing with big numbers and estimations. So, working with big numbers, they can be intimidating, but there's rules that we can still apply to them that let us get quick estimates or let us quickly do math even if it's dealing with big numbers. One of the easiest rules is just multiplying by 10. So you may already know, multiply any number by 10, you just add a 0 to the end. So 5 times 10 is 50. Actually, yeah, grab my little drawing tool. 5 times 10 is 50. 3 times 10 is 30, and in this case, even a big number like 253 times 10 is just, we stuck a 0 on the end, so 253 times 10 becomes 2,530. That's maybe not all that useful on its own, only when you're multiplying by 10, but you can also do it with any multiples of 10. So 100 is 10 times 10. So if we multiply a number by 100, that's the same as multiplying it by 10 twice. So say 253 times 100 is the same as 253 times 10 times 10. That means add one 0 to the end, then add another 0 to the end. Or 253 times 100 is 25,300. We've just stuck the two zeros here on the end of that number over there. And so that works with any number of multiples of 10. So here we've got 100,000 that has 1, 2, 3, 4, 5 zeros, and we've just stuck those 5 zeros on the end over here. So, and then you can add on to that process. So say we need to multiply these two big but simple numbers. So 2,000,000 and 300,000 are big, but they all have a bunch of zeros on the end. Well, to do that, if we didn't have a calculator, we could say, well, 2,000,000 is the same as 2 times 1,000,000. Two individual millions make 2,000,000. Likewise, 3 times 100,000 is 300,000. So if we separate those out and according to order of operations, to multiplication you can do in any order if you're just multiplying. So we can put the 2 and the 3 together for 2 times 3, and then we can put the 1,000,000 here and the 100,000 together, meaning we just need to do 2 times 3, which hopefully you can do, is 6, and then combine our 5 zeros from 100,000 with the 6 zeros from 1,000,000 and get 2 times, see, even I lose track of numbers. 1 billion. Yep. So we wind up with 6 billion, or sorry, 600 billion. Um, yeah. Division, you can work the same way. So if you're dividing by 10, so 50, same way we said 55 times 10 is 50. 50 divided by 10 is 5, so just chop a 0 off the end, and that continues to work with big numbers, so 170 divided by 10, just chop that 0 off the end is 17. 230 million is what that is. Divided by 1,000, we just got to chop off 1, 2, 3 zeros from the end, and wind up with 230,000. Uh, Likewise, we can do that, so they're recommending rewriting as a fraction. So if we had to do something like 6 divided by 3, we could rewrite it as a fraction of 6 over 3 equals 2. And we can also we can simplify fractions by dividing the numerator and denominator by the same thing. So 12 over 8, divide the top and bottom by the same number 4, we get 3/2, the simplified fraction. So similar idea with big numbers. If we have something like 800 million divided by 20,000, well, let's just divide the top and the bottom by 10,000 so that we can chop off 1, 2, 3, 4 zeros from both of them and get 80,000 divided by 2 is 40,000. And so you may not even need to do all that whole process once you get used to it. You can just chop off the same number of zeros from the top and bottom, and then see that we're doing 8 divided by 2 uh, to give us 4, and then tack on the remaining 1, 2, 3, 4, 0. So as a quick example here, we've got a truck that travels 2,312 miles in a week with diesel that costs $4 and 27.7 cents. We're getting into fractions of a cent, which will matter if you get spend enough on it. But and it gets 8.9 miles per gallon. We want to know the weekly cost. So since we just practiced doing things with powers of 10, let's do that. Let's round this 8.9 miles per gallon. Let's say we can get a whole 10 miles per gallon. So this is a unit fraction. We'll talk more about that. But basically, we've taken our ratio here. We've averaged it a bit, or we rounded it a bit. Now we're saying 10 miles. Every 10 miles of travel corresponds to 1 gallon of gas. We've written it as a fraction like this. Likewise, we can say 1 gallon. Every 1 gallon of gas gives us 10 miles. So write it like this. Actually, let me clean it up a bit since I got ahead of myself. And then, so 1 gallon is every 10 miles. And what we're going to do is we're going to multiply that by the 2,000. Get rid of that. The 2,000-ish, so around 2,312 to the nearest 1,000 miles we have to travel. So that's miles here. So ultimately comes down to is 2,000 divided by 10. We can cross a 0 off of both the ends of these and get 200 gallons. Also, as we practice with unit fractions, we'll know that miles cancels with miles, canceling units like you do numbers, and we wind up with just what we need to know, that it's going to take us about 200 gallons of diesel to get us our travel for the week. Then we can go down here. We're going to once again round that it's about $4 for every 1 gallon of gas. Turn it into a fraction like this. We're going to multiply it by the 200 gallons that we need and get that it's going to cost us about $800 to cross it, because 2 times 4 is 8, and then we just tack on these 1, 2 zeros to the end. So that's a quick estimation we can do if we don't happen to have our calculator on us, which is becoming less and less common, but could still be handy. And let's compare that to the real result. So we want 2,312. This is just Wolfram Alpha, useful online calculator I recommend, but you're free to use other ones as well. Divided by the 8.9 gallons, we get for that times the 4.217, and hey, we get 1,095.47 for our weekly cost. So we underestimated our cost a little bit, but we weren't too far off for our $800 estimation. So that's become a bit less useful over time, because now, back in the days of teachers said, oh, you're not always going to have a calculator in your pocket. These days, everyone who has a smartphone does have a calculator in their pocket because it has that feature. But it can still be useful for double checking yourself or realizing something's wrong before you go and, I don't know, use it, put it in an official document or something. But let's say we're computing taxes for a year. Right. So for an example that I think that still makes this technique a bit useful, even when we all have calculators in our pocket, is to double check our math. So let's say we're doing taxes. We need to find our yearly income. We can start just by figuring out how many hours we work. Let's say we work most of the weeks out of the year, so 52 weeks out of the year, and we work 8 hours a day, and then we work a 5-day work week, 9 to 5, so that'll be times the 5 days that we work each week. and if we plug that into a calculator, we get 15 times 8 times 5. So that one's not going to particularly be helped by our new technique, but we'll get 2,080. Then, so take that $2,080 and multiply it by, let's say we get paid $20 an hour. Gotten a little messy as my tablet started fighting me, but whatever. So we can plug that into a calculator. And let's say I got 2100. That's clearly not right. In this case, the error is kind of obvious. I hit the plus key instead of the multiplication key. But what makes this technique still useful is I can see that error just by the number of digits. So, one, it doesn't make sense that I made only $2,100 in a year. But if we count our digits here, so this thing has 1, 2, 3, 4 digits. This has 2, or this has a 0 on the end. So we should get at least one more digit out of this. So we should be able to multiply and get the correct answer of 416,000 or 41,600. So this technique, even if you're not dealing with perfect zeros, can be useful for getting, are we in the right ballpark with our answer? So we had a number with 4 digits. We multiplied by a power of 10 or something in the tens section. So, 10, 20, 30, 40. Something, actually the easiest way to say it. If we have something with 4 digits and we multiply it by something with 2 digits, we should get something with about 5 digits. We should add one extra digit because of this second digit here. And this could be applied more generally. So now let's just make up a wild number. So let's say for some reason I'm multiplying two big numbers, like 3,317 times, excuse me, 251. Um, so we can't use our new technique to do that exactly, but what we could do, so that's a 3-digit number, 251. We can treat that kind of like, let's multiply 3,317 by 100. We would get what I've got written over there already, 331,700. So that's not what we're going to get, of course, but it is a 1, 2, 3, 4, 5, 6-digit number. We had a 4-digit number. We added 2 more by multiplying by a 3-digit number, or a number with 2 spots at the end, I guess you could call it. So let's see here. When we actually plug it in, we get 3,317 times 251 is 832,567. So we get a number that is indeed 6 digits. Let me make sure. 132, 567. When we multiply it. So you typically, can be a good double check method to make sure you're getting approximately that. Sometimes you'll bump up a digit, so let's say 3,117 times 957 gives us 303,174,000 469. Can I just copy that? Save myself some time. Yep. But we get a 1, 2, 3, 4, 5, 6, 7, 8. So this technique gives us how many digits we expect. If we multiply a 4-digit number times a 3-digit number, we expect either a 6-digit number or a 7-digit number. So maybe hopefully that's a little useful. Yep. See you guys next time.